to the video solution of the given question. So there is an induction motor. The supply voltage is the rated voltage, but the frequency is decreased by the half of the rated frequency. So what will happen to the speed of the rotor? So when the frequency is decreased by half of the rated frequency, the XL, that is the leakage impedance, is equal to 2 pi FL. Yeah, it will 2 pi FL. Now the leakage impedance will become the half of the rated impedance, or rated leakage impedance, and we know that the current I is equal to V by voltage by impedance. But when the stator is considered it has very less resistance compared to the leakage impedance, so we neglect the resistance and we can write current is equal to V by XL approximately. Now the XL is decreased by 2 times. The current will increase by 2 times. If we consider the saturation, then the current will be more than the 2 times. So when the current is 2 times of the rated current, it will generate the overheating. So how this overheating will be happening? Like there will be, this is a conductor, this is an atom. When the current is increased, the number of electrons flow will increase. When number of electrons flow is increasing, the collision with the atoms will increase. These collisions will result in the heat, and the more collisions, so more heat. So heat will be increasing the exponentially as the time passes. Like at rated current, the generated heat equal to the dissipated heat. But when the current is 2 times the rated current, so the heat produced is greater than the heat dissipated, then the heat in the conductor will increase exponentially. At certain point, the heat in the conductor will it will rise the temperature, and this temperature, when it reaches to the melting point of uh, the conductor starts melting. When conductor starts melting, it will get open circuited. When it get open circuited, there is an electric field here. It will ionize the air gap between this region. So there is a spark is developed here. This spark will burn the windings. And we can say that whenever the current is increased by 2 times, there is another case also. There will be two conductors. They are insulated, and now the current is 2R. The force between the two adjacent, the same uh, carrying currents in the same direction will be directly proportional to the I square. Now it is 2 times the rated current. The force will be the 4 times the rated. So it will be the force will be increasing by 4 times. When this much of mechanical force is applied on the insulation, there will be a rupture of insulation, and these conductors will get short circuited. When they get short circuited, they will, due to the electric field of this and this, it will ionize the uh, air gap between them, and there is a spark develop and it will completely burn off. So when the windings get are getting burned, so there is no magnetic flux, so the rotor speed will become uh, to 0. So we can also explain this in another manner. We explain this by equation. The current is increasing by, we express by equation. We can also go with another explanation. Say this is the winding of the stator. So this is the case where P rated and frequency rated is applied. Here is the voltage rated and FR rated frequency by 2. So when we are applying the voltage here, there will be an EMF induced in the stator winding, that will be N d phi by dt. So here now we are decreasing the frequency by 2 times. So the frequency is inversely proportional to the time period. So since the frequency is decreasing, the time period will increase by 2 times, and the E is equal to N d phi by dt. This dt will increase by 2 times, and when it is increased by 2 times, the voltage will decrease. When voltage decrease, there is a transient current is produced here, because if it is 100 volts AC and here it induced is 50, then there will be a transient current is produced until this induced EMF will reach the supply voltage, that is 100. So when the current is starts get increasing, then the flux starts increasing. At certain point, the EMF induced will be equal to the supply voltage. So since it is the time period or the dt is increasing by 2 times, the flux should increase by 2 times. So in order to increase the flux by 2 times, here since it is a rated current, here it is a rated current, so in order to draw the 2 times the flux, the current will be more than the 2 times the rated. So uh, from by this we can say that the current will be the greater than the 2 times the rated current. Thank you.